So, I mean, you could say the benefit of any cryptocurrency is that it's decentralized, which, the people who don't like the fact that the government can print more money just at a whim, that's bad. The government, why do they get to make that decision? Blah, blah, blah. So, cryptocurrency, new currency is born every some number of minutes and it's based on a math algorithm. So there's not a person who's in charge of that. Well, then you're in this situation where if you do get scammed, so if you get scammed in real life, you swiped your Visa for something and somebody didn't send you the thing, you complain to Visa for fraud. Visa takes care of it, right? Or you complain to PayPal for fraud, they take care of it. There's nobody to complain to in crypto. So fine, it's decentralized. You've taken the decision out of the corrupt governments or whatever, or taken the power away from the banks, but you've also lost your target for who to complain to. At the end of the day, people we want our cake and eat it too. We don't like trusting people, but we accept that we have to trust somebody. So we would probably trust places like Amazon. We're like, even though that's the way it typically works, most of us would probably, if we wanted something, we would send an envelope of cash to Amazon, and we would trust that Amazon would send us the product because Amazon has a track record of fulfilling sales, right? But would you trust, Bob, the hardware guy? He's like, look, I'm gonna send you an envelope of Chinese yen, and you're gonna send me back, a PlayStation 4 or something, and it's a 50-50 crapshoot whether they're gonna send anything, right? So that's the level of trust. People earn your trust in real life, or in crypto, trust is out the window. Basically you say, I'm not going to trust anybody. So now what you're going to have is you're going to have infrastructures built around it where companies are going to start becoming kind of escrow houses where, if I'm buying a product from this guy will send product to the middleman. I'll send coin to middleman. That middleman who I trust will do the swap and send them on to the destinations. Well, now we're right back to trusting people. But the people we're trusting aren't the ones who choose when coin. So we're just changing the relationship of the trust. Who knows? Who knows? It's fun. It's computer sciencey. It's pushing technology forward. Blockchain is the important part of that. The currency aspect is just an offshoot of that. The one application of blockchain technology is cryptocurrency. But blockchain, that idea, that computer science concept, is the cool concept. That's the part that's going to be very much part of our future technology regardless. Bitcoin doesn't need to take off for that to be a thing. But the cryptocurrency is fun because it makes you feel like you're part of the gold rush, right? All those people that ran, they were going to out to California with their little pickaxes, like, I'm gonna make $1 million, or back then it was I'm gonna make a dollar in gold. Yeah, so it is what it is.
When did Bitcoin start?
Probably maybe 10, 11 years ago, 12 years ago.
Really?
2009. Okay, so yeah. That was when the original white paper was released. Satoshi. Okay. Well, anyways, I guess I'll invite everybody else. If you're interested in learning more about the cryptocurrency stuff, I'm meeting several students here tomorrow, Saturday at 10 a.m. in this room. So if you are interested, just show up here at 10 a.m. and I'll give you as much backstory as you want. Other thing is I put up a post on General this morning. Everybody see my post I put up on General this morning on Slack? Well, go and check it out. I have one extra ticket to Black Panther at 3:25 today. So if you're going to see the movie and you're free at 3:25, the first person who private messages me gets a free ticket to the movie. If you happen to need a ride, I'm leaving campus around 3 o'clock to go over there. It's just here in town. But free ticket to Black Panther if you are interested. I'm going with like 3 other people. Well, you got a cell phone, don't you? You have Slack on your cell phone?
It's a band.
So I'll look at timestamps after class.
Yeah,
Okay, so let's talk about some more Java stuff, and hopefully we get into some Python stuff. Let's see, where are we at in Mendix? So we have 2 more modules after this. So over the weekend will be our last modules. The one thing I'll point out, and I'll be giving you an assignment next week, and I'll treat it as maybe a little extra credit or something like that. Kind of a survey. I'm doing some research related to Mendix at a conference in New Orleans in July. Who puts a conference in New Orleans in July? That's a terrible place to be in July. It's about 300 degrees and 140% humidity. It's terrible there. But in any case, in general, what's our current perception of Mendix? How many of you love it? Okay, very few hands, right? How many of you completely hate it? You get several, right? Okay. How many of you think, okay, it's okay, but I can't wait till we're done with this? Kind of most of us, right? Now, I think it'll make some sense why we're using it after you finish the stuff and I pull the strings together afterwards. But some interesting stuff is, how many of you have heard of a school called MIT? Okay, so a pretty good computer science school, right? Probably one of the top 2 in the world. They have an entire class on Mendix there. So the tool is an industry standard tool. It's just because this class isn't on Mendix, I'm kind of relying on these videos for you to kind of push you through it while I'm doing this other stuff. So you're kind of at the mercy of how well the tutorial kind of teaches it. So that's maybe why it's a little bit of a crapshoot. But in any case, it's introducing some stuff that'll be important that'll make sense next week, and I'll talk about the research paper I'm working on related to that, and it's related to computer science education with it. Okay, so let's pick up where we left off here. So we've been talking about the history of our programming languages. So we kind of have a picture that looks like this right now. So we started off at C, then we went to C++. From C, problem with C++ is it empowered the programmer to make bad decisions. So we can hand somebody the house instead of the address of the house. So now we have Java. So let me just flip through this real quick. So let's see, we have a memory, we have conversion stuff. We talked about functions, talked about C++. Here's our problem with C++. We talked about iOS versus Android. We talked about Apple, Microsoft history, Steve Jobs' stuff. Talked about how Apple today is actually next computers with an Apple logo. All right, so now this is kind of still actually part of the Microsoft backstory. So this language comes out called Java. You know who made Java? So the Java programming language was made by a company called Sun Microsystems. How many of you have heard of Sun Microsystems before? So if I go to open up a web page now and I go to java.sun.com, it'll go to Oracle. So the company Oracle acquired Sun Microsystems many years ago. How many of you heard of Oracle? It rings a bell. So many people in here have heard of Oracle, the company, right? How many of you know what Oracle makes? What's Oracle? Well, Oracle's famous for one specific. They have a product called Oracle. Yeah. So Oracle's a database company. They make a kind of an enterprise level. Probably considered to be one of the fastest databases out there. They make a database management system called Oracle. But that's an interesting kind of a company concept, right? Many of us maybe have heard of or seen the logo for Oracle at a baseball stadium or something like that, but have no clue what they do. I think they're in tech, but I'm not sure. They might just be more of like a kind of almost like the McDonald's of like, palm reading or something. Oracle. That's what oracles are, right? They're like soothsayers. Or,
stuff,
yeah. That would be really funny. It's like a fast food chain for palm reading. You go through, you can get your tea leaves read, or you just order off the menu. It's like a Starbucks. I'm actually surprised Starbucks hasn't started doing stuff like that. It seems like it would maybe go with some of their. Yeah, maybe. I don't know. Huh?
Tea reading?
I don't know, just something. Or having like little seminars on reading tea leaves. Seems like a Starbucksy type of thing.
Starbucks should sell those shoes like the
Yeah.
shelves next to the drinks.
All right, so Sun Microsystems created Java. In fact, they believed in Java so much. So when Sun was on the stock market, you know how companies on the stock market have a ticker symbol? So like Apple is AAPL, Microsoft is MSFT, Google is, well, used to be GOOG. Sun Microsystems was Java. That was their ticker symbol. All right, so they believed in Java a whole lot. Now, what happened in this story is Microsoft stole Java, as Microsoft does. Right, so anyways, they stole Java. Really what they did is Microsoft, they have a product called Visual Studio, okay, which is their integrated software development tool. And they released so it's a collection of several languages. So Visual C++ comes with that, Visual Basic comes with that, ASP comes with that. Now what they did is they released a language called J++. Now, so the idea is that Visual Studio lets you build graphical user interface applications specific for Windows. So it allowed you to make Windows native applications using Java syntax, if that was the language you were familiar with, because Java was pretty popular at the time. All right, so they came out with J++. Now, typically, if you're some kid who made some piece of software and Microsoft comes and steals your software and then settles outside of court with you, you're okay with that. You got your $1 million, you move on with life because you probably didn't have the resources to make that off whatever your product was anyways. But Sun Microsystems isn't just some little kid. So Sun Microsystems sued Microsoft and won. Look, you can't steal our crap and then just get away with it. So they sued, and actually in the middle, J++ turned into a product called J#. They just moved the plus signs closer to each other, right? So this was kind of more of a branding thing that Microsoft started doing. So that was like kind of during the lawsuit, and then they lost, and now Visual Studio doesn't have any J's in it. they've lost the J's. So anyways, Sun sues Microsoft and wins. Microsoft creates brand new language called C#. All right, and if you remember from our picture back here, we have this language hanging off here, C#. It's just a little bit farther down the lineage line than Java, but these guys are kind of in the same general neighborhood because of when it came out. Because Microsoft jumped on this bandwagon, then got sued, and then created this bandwagon. All right, so let's talk about the differences between these guys. All right, so and again, this isn't even to demonize Microsoft. It's not the first time a big company has stolen something that didn't get away with it. All right? Just Microsoft happened to be part of this story. It is what it is. All right, so Java kept variables. They kept arrays. They dumped structs. So remember, structs are this collection of name-value pairs. I think somebody last class mentioned, is that like a dictionary in Python or something like that? Which we haven't necessarily talked about those yet, but yes, it is. It's a dictionary in Python. So Java got rid of this thing called a struct because what Java said, and if you remember when we went from C to C++, we talked about structs, and we said that a weakness of a struct is you couldn't have embedded functions. You can't put abilities into a struct. All you can do is store pieces of information. First name is Mike. Last name is Littman, so on and so forth. You can store just name value pairs, but you couldn't have functions built into it, so you had to have your functions sitting separate, and then you would pass a struct to it and operate on that struct, where it would be maybe nicer to have our telephone look like a telephone instead of the big pile of wires. Okay, so that's where the object-oriented languages came from, and Java is one of them. So, but C++, being an object-oriented language, kept structs. They just gave you a new organizational tool called a class, which you would use instead of a struct if you needed to do more than just store data. If you had to do more than just store name value pairs, you would use a class, because now you can write functions into it. Well, Java comes out and they says, you know what? They say, really, a struct is just a class that you choose not to write functions in. So why do I need both of those tools? When if you need the functionality of a struct, you could just create a class and just not write a function. Just a class just has some name value pairs in it. So Java says, so because of that, we're going to get rid of structs. It's redundant, that type of thing. And the reality is it's almost redundant. All right, and this is something that we'll talk about in more detail later, but I'll talk about at the high level right now. So, so we have this idea called parameter passing. So when we're passing variables into a function, and when we're actually sending them into a function, they are passed one of two ways. They are either passed by value, or they are passed by, historically it's usually called reference, or by address. Okay, now this is related to that comment from a couple classes ago when I said that a language like C++ empowers the programmer to say, hey, I'm having a party tonight. Here's my house. Open the door at 8. That's me passing that house by value. I'm giving you the actual house. Okay? As opposed to me handing you a piece of paper that has the address of that house on there, which is a reference to where you can find the house. That's a lighter. Okay, right? So now, some things innately are passed by value. Other things are passed by reference, by default. So for instance, if I'm giving you a number, okay, I'm not, like, let's say I'm going to give you a quarter. Let's keep it in real life. Okay, I'm going to give you a quarter. Am I going to hand you a quarter and say, here you go, you need a quarter? Make a phone call or something, a phone booth. Or am I going to hide a quarter somewhere in this building and give you a piece of paper where you can find that quarter?
That's more fun though.
Okay. That might be more fun, but that's not how it would work, right? So we would say quarters are nice and tiny, not really, they're not memory inefficient. So I'll go ahead and hand you the actual quarter. That makes sense? Now, in the reality is we're really connecting this to programming. What I'm actually going to do is I'll take the quarter out of my pocket and I'm going to duplicate it. It's a magic trick. If we could do that, you might have a lot of quarters, but you'd just be a zillionaire of quarters, right? But I'm going to duplicate that quarter so I actually have 2 quarters. Okay, so now I'm going to hand you a real quarter, but if you throw your quarter away, you melt it down, it won't impact my quarter. That's what's actually happening when I say pass by value. So I'm handing you a copy of the value. Okay, so if I hand you a variable A, I'm giving you the value that A holds, but I'm giving you a copy of it. So anything you do to it won't impact this guy over here. So what I'm saying there is we typically say that this guy has no side effect. So if I give you something by value, you can do whatever you want to it and it won't damage the original. If I give you something by address, so for instance, I give you the address to my house and you run over there and spray paint the garage, when I get home, I'm going to notice, right? Because we're operating off the same house there. All right, so has side effect. Okay, and these things are going to make more sense as we start bringing these concepts together, as soon as we dive into the Python stuff. But at the high levels, we're talking about the languages. These are a couple of things. So in a language like C and C++, the programmer was completely in control over how these things got passed around. We got to choose whether I'm going to pass something by value or pass something by reference. Okay? even though in real life we've mentioned that it would never make sense to hand somebody a house, right? And certainly in the early days of programming with memory being so expensive, it definitely wouldn't have made sense. But today, memory is really cheap, so you might be in a situation where you might say, look, I know it's memory inefficient, but I don't care. And I really don't want them to be able to spray paint my house. So I'm going to give them a copy of this really, really heavy thing because I can. All right, so it still wouldn't be good programming practice 99% of the time, but there might be a situation where passing something that's very large by value actually makes sense. Okay? But that's the exception, not the rule. Typically, you want to be as memory efficient as possible. So what a language like Java did is they took a lot of that decision making away from the programmer, to so that we couldn't hurt ourselves. It's kind of like putting safety locks on things, baby proof in the house. Right? It really is kind of like baby proof in the house. So we can't just screw up as often. We're going to have our own problems. So what they did is they said, you know what, a struct and a class are the same thing as long as you don't write any functions in the class. So if you need to do the struct stuff, just create a class and don't put functions in it. And that's almost true. Structs versus classes. By default, structs are passed by value. Classes are passed by address. So if you don't go out of your way to, in a language like C++, if you don't go out of your way to change the default way these guys are sent, a struct is passed as a copy by value, passed like a quarter would be passed, where a class is passed like me giving you the address to my house. Now, maybe we could even say 99% of the time that's not going to make a difference. Does it make a difference whether, let's assume we had enough memory. If I hand you my house or I give you the address to my house, does it make a difference if you don't change my house?
No.
Yeah, if you make no modifications to the house, it doesn't matter whether you had a copy or the actual address of the house. Mm-hmm. And maybe we say, look, most of the time when you're passing information to a function or something, you're giving it because you just need to use some of the data from that. You're not actually modifying that object. When I hand somebody my cell phone to make a call, they might go in there and screw with stuff, but generally you're going to make your call and you're going to hand it back. You're not going to go delete my contacts and all this other stuff, right? It's you're using that object but not abusing the object or something like that. All right. So maybe we can even say most of the time this differentiation didn't matter. It was more just a memory consequence, which today we don't care about in general, right? But what if it did matter? What if you were passing something and you intended to change it? You might pass a struct, you might make a change to it expecting that change to globally have side effect, and it won't. Or you might pass a class thinking it acts like a struct. So maybe you're an experienced C++ programmer and you know that structs are passed by value by default. All right. So then you say, oh, well, Java says a class without functions is just a struct. So you pass an object, you pass a class to a function, you make changes to it just like you've historically made changes to a struct, expecting those changes not to have a side effect, but then all of a sudden you've broken another part of your program because it did have a side effect. Go ahead.
Isn't there a way to change so that the opposite is true for the default?
In C++, yes, not in Java. Java takes that decision-making away.
Oh,
That's where that comment about C++ empowers the programmer to make decisions. I'm going to actually show you an example of that here in a second. So we'll look at a little scary programming here in a second. Yeah, so Java says, hey, we're always going to make the right decision for you. And maybe most of the time they do. As long as if you're considering memory efficiency, Java probably does make the right decision for you. So, we're probably talking 99% of the time, Java is helpful to us. What's really bad about a language like Java, and it's kind of the reason why I go into such detail behind the scenes. If you take a traditional computer programming class someplace, you're typically going to be much more applied early on. We're going to be very applied for a majority of the semester. But up front here, we're doing a lot of background information. Okay? I've been doing this for a few minutes. Trust me, this will benefit you. Okay? Because what ends up happening is modern universities start turning out people who can write using modern programming languages. But they don't understand these underlying concepts that end up then biting you in the butt at some point in time in the future. Because you know how to use a modern language, but you don't know where that stuff came from. So when you run into a kind of a difficult problem that's a little bit outside the ordinary, you don't have that theory knowledge to fall back on and say, oh, well, this is going to work this way because of this other thing. Since you learned this evolved language that was, came years and years and years after the older languages, you had all that stuff hidden from you. If you drive a car, none of us in here have ever had to get outside of the car and, crank the engine by hand to get it to turn over. Okay? Unless, you were driving a Model T or something like that. Okay? So generally speaking, we've all had cars where you get in and you turn the key. And, it comes on. Okay? Imagine in the winter. Sometimes, our automatic cars, it takes a little bit of a coaxing to get to turn on in the winter, right? Imagine if you were outside cranking the engine by hand to get the thing to turn on, or warming your horse's saddle, so that it'll take off. That's we haven't had to live that, but we can sort of kind of appreciate that would suck, right? Even now, even in the summer, I have a remote start on my car. When I'm within range of my car, I turn it on. So the air conditioning, I don't want to have to be too warm or too cold. I turn it on. That's how lazy we've become. But we start relying on that, and if we don't appreciate how it used to be, I'm not a professional car person, so I don't have to rely on having this deep down knowledge of how cars work and things like that. But being a computer scientist, I should probably know quite a bit about how computers work and how languages are put together and stuff like that. So too often what we're doing in education today is we're pumping people out who have applied knowledge of modern stuff, but don't really have a foundation of where that stuff came from. And sometimes that's going to hurt you. Okay? So in any case, if you are an experienced C++ programmer and you've moved over to the latest, greatest tool, Java, and all of a sudden you say, okay, well, Java's taken away structs from me, and I'm used to using structs all the time. I'm going to go ahead and take Java's suggestion. I need a struct, so I'm just going to create a class and not put functions in it. Now I'm going to pass it to this function, and I'm going to make some changes to it because making changes to the struct does not have side effect. All of a sudden it does in Java because it was actually a class and it was passed by reference, passed by address. All right, so it's little things like that where when Java makes this decision that a struct is not needed because a class without functions is exactly like a struct is a slight lie. It's almost exactly like a struct except for how things are passed. So if you're coming from an older language, you kind of have to learn some of those little idiosyncrasies of the new language. Not the end of the world because there is a workaround. Go ahead.
So does JavaScript then, would that give you the option?
Well, first of all, JavaScript and Java completely unrelated to each other.
Yeah, I know.
Yeah, they have nothing to do with each other. Yeah.
I thought it was like a successor or something.
Yeah, they both are based on C, the C programming language, but the fact that they both have the word Java in them is their only relation. Yeah, they're not based on each other at all. They're both based on C. JavaScript, pretty much everything is passed by reference because it's an interpreted language. It's for different reasons. Yeah, but don't use knowledge of Java to make a guess at how JavaScript necessarily works because they're not related other than name. It's a little misleading, actually.
I was about to say, why would they call it
Just a thing. I think actually, so JavaScript came out first.
Really?
Yeah, and it was a web scripting language, and I think it had more to do with like the people who were writing websites. They would do this in coffee shops with Java. Like the logo for it was a cup of coffee.
I think I vaguely remember that.
Yeah. So in any case, let's look at kind of an older language here. And I'll even use an old text editor so we can be, really retro. Okay.
Yeah.
So we're going to do CSC200.c. So we're going to write a little C program. So this is stuff from 1968. All right, so we'll open up our text editor here. And so VI, that's the text editor you should all aspire to use, because this is before mice existed. So this is a text editor that was designed. So I mean, you couldn't go up and hit File Save. You didn't have that. You didn't have it. There's no mouse to go up and hit File Save. So the idea of VI was supposed to be high performance. So if you were a touch typist, you never actually had to take your hand off the keyboard. So you actually give commands to it. I'll point out when I do this in a few seconds, which actually kind of sucks on this machine because I'll explain in a second. So I'm going to go ahead. I'm going to put it in insert mode so I can type stuff. And we're going to go ahead. I'm going to do we'll include a standard input output so I can write stuff to the screen. And we'll do int main, int argc, char, pointer, argv. And then we'll go ahead and say print f, hello world, do a little \n there. All right, so that's our simple hello world program in C. I'm actually going to show you a little bit more than hello world here in a second, but usually the first program you write in any language is hello world, just to kind of get the basics of that language. So now I want to save this file, so I have to hit escape. And on the newer MacBook Pros, you don't actually have a physical escape key. The escape key is in the little, like the cool little LED panel thing that can basically useless. It's a good way of finding emojis. Yeah. So I have to hit that and hit the escape button on that. Then I put a colon. Then I put a W to write. That saves. And I can just press enter now and it'll save. But I also want to quit so I can go out and try to compile this. So I'm going to do WQ, write quit. Press enter, so now it saved it. So now I'm going to go ahead and compile this guy with the C compiler. All right. And it's going to run, blah, blah, blah. Everything's good. It just created a file for me called a.out. So I'm going to go ahead and run a.out. That's my executable. And there's my hello world. All right. So that's old school C programming. Now, we were just talking about C and C++ give you the ability to directly manipulate memory. All right. They allow you to get into trouble if you don't know what you're doing. And let me kind of show you that special syntax so we have a reference for this. So what I'm going to do is I'm going to create an integer called a. I'm going to set equal to 5. All right, and then I'll come down here and we'll just do a printf. A is %d \n a. All right, so %d is a placeholder for a decimal value, like an integer. So this program is going to print out, it's going to just say the text. A is colon, and then %d is going to be replaced with whatever a holds. And a holds an integer, which is 5. So this should print out a is 5. All right, so we'll start with that. Compile this guy again. Run it again. There's my a is 5. Now, in older languages, we had a specific type called the pointer. So integers can hold whole numbers, positive and negative whole numbers. Floats can hold positive, negative decimal numbers like 3.14, stuff like that. Chars can hold characters, A, B, C, stuff like that. Actually, a little bit more than that with chars, but we'll talk about that later. Pointers are a type capable of holding a memory address. Now, typically, beginning programmers struggle with pointers. In fact, it's probably the reason why we don't use C or C++ as the first programming language. You just get scared too quickly, and then it's hard to keep you in the program. All right, so let's look at this. So what I'm going to do is I'm going to create another variable here. I'm going to create an int pointer named B. I'm going to set this guy equal to the address of A. So those two little symbols there, the asterisk and the ampersand, were taken away when we went to Java. We do not have those two little tools that allow us to directly work with memory. So I created a variable here named B, capable of holding the address of an integer. What am I going to put in there? I'm going to put in the address of my integer named A. Now I'm going to go ahead and print that out. So I'll do a little comment there. We'll say B is %P for pointer. And then I'll put B in there. So the first placeholder, A will replace. The second placeholder, B will replace. So this guy is going to be a decimal. This guy is going to be a pointer. We'll go ahead and run this. Okay, we get our A is 5, and then we get B is something intimidating. Okay, this is the real problem. Memory addresses look scary, right? How many of you are slightly intimidated by that? Okay, we should be at least slightly. All right. Now, what's funny about this is this kind of comes back to this idea that in technology, we often have things that seem hard that are actually quite easy. And it all comes down to how human beings were such good problem solvers that we have trouble articulating how we solve problems. We also aren't that adaptable to other ways of doing things. So in real life, we have things called addresses, right? You know, like you have an address to your house. Now, the address to your house is pretty complex. It has a number, it has a street name, it has a city name, it has a zip code in case there's two cities with the same name, right? Also has a state to make sure you're in the right state. So there's a lot of pieces that go into an address. So if somebody gives you an address anywhere in the world, with some level of effort, you could get to that place, right? You can go look it up. That's complex. Computers are way easier. Every house is on one big long street. Okay? Every house is on one big long street. Now we've already done number conversion crap, right? So this guy right here, this is just a hexadecimal number. We could convert that guy to decimal. We'll get some big long number, right? Some giant decimal number. So let's say it's house, 731. We'll make it a smaller number. Okay. So this is house 731. Okay, well, I'm just going to start at the beginning of the street. This is house 0. This is house 1. This is house 2. I'll go all the way down to house 731. I'm at that address. That's it. No street name, no city name, no zip code, no state. Just keep going till you get to house number 731. That's easy, right? Okay. But it feels intimidating because they are represented in hexadecimal values because our memory is so large today that memory space is big. So if we represented, here, let's go to the extreme. If we represented each house by its binary equivalent, you know, the house all the way down at the end of the street would have 32 characters in it, or 64 characters in it, depending on, you know, if we had a 64-bit memory space or something like that. Yeah.
So the 0x not part of the decimal.
That tells us it's hexadecimal. That's like the visual, in computers. But relatively unimportant for us. We talk more about this stuff in like a computer organization class. So I think I've mentioned it in here before. There's a concept that Dr. Locklear talks about a lot called the grand ideas of computer science. So one thing you're going to notice as you take a lot of computer science classes, you should hear the same concepts multiple times, but through different lenses. Okay, so when we get into computer organization, we'll really talk about how memory works. And here we just want to have an appreciation that we have this big long street with numbered houses, numbered spaces in memory. Make sense? All right, so I might ask you to like convert a number. I wouldn't ask you to convert this large of it. Actually, that would be a really like just junky test question. Like, look, here's a number. Convert that to binary. Actually, that wouldn't be hard to convert to binary with the trick, right? Each bucket of, I've shown you the trick, right? Where hexadecimal can be in 4 bits, octals 3 bits.
No.
Oh, really?
We don't talk about it.
Remind me next day. Let me just write a slide real quick. Show hex trick. Hex/octal trick. And it's not really a trick. It's actually the rationale why we use octal and hexadecimal, why those are common things that are used in computers.
Okay.
All right, so let me just finish this up real quick in our last minute. So A, so if I want to say the address of A here, then I would say A is actually going to be a pointer, and I'm going to print out the address of A. And if I want to say what the value at B is, star B, then I would print out, I know it's a decimal because it's an integer, and I would print out star B. So now I would get crazy address followed by the 5. Star B says, give me the value found at that memory address. Ampersand A says, give me the address of this value. Make sense? So punchline for us is in languages like C and C++, we had control over whether we were working with values or working with memory. In Java, we do not. Java's taken that ability away from us, right? Which saves us from ourselves, let's call it most of the time, but then sometimes does take some flexibility away from us once we know what we're doing. Make sense? All right. Bible homework is up, but it's not due till, if you notice, it's not due till midnight on Sunday because I got it up late this week. And then I'll put your next assignment up. It's the next 2 modules in Mendix. So stick to the Mendix thing. If you run into some struggles, just kind of try to get around it or something like that. I will be giving you kind of an extra credit survey next week I'm going to use for my research for your opinions on Mendix, what's good, what's bad, what needs to be fixed, blah, blah, blah. I'll see everybody on Monday.
I'll
I message you. I'm free at 3.